Hello and welcome. It's called a TCP SYN Scan, or a stealth scan. It is the #1 method cybercriminals and penetration testers use to map out open ports. But what does this look like under Wireshark? If you look at packets one by one, you will get confused. But if you look at the Conversations tab, the math tells the whole story. In this video, we will use Wireshark statistics to find the attacker's IP instantly, see every port they targeted, and analyze the attack using simple numbers. Let's get started. After opening the captured PCAP file, we will use the Wireshark statistics to analyze and see what a TCP SYN scan with Nmap looks like. We head over to Statistics Conversations. Click on the IP tab, and then double-click at Packets tab to sort them. We can see that 2023 packets were exchanged between address A, ending in .223, and address B, ending in .208. Address A sent 1,023 packets. Address B responded with exactly 1,000 packets. Now in a standard SYN scan, address B will only reply once to address A for each probe. It sends a SYN ACK packet if the port is open, or a reset ACK packet if the port is closed. So, let's break down those 1,023 packets sent by address A. They consist of 1,000 initial SYN packets, which is one for every single port tested, plus 23 reset packets sent back to address B in response to its SYN case. This math tells us one thing clearly: there are 23 open ports. Here is how an open port looks like in Wireshark during a SYN scan. We'll use a filter for port 80, which we know is open. We type tcp.port == 80. We see that it follows a strict sequence: SYN, then SYN ACK, and finally reset. Address A sends a SYN packet, address B replies with a SYN ACK, and then address A immediately tears down the connection with a reset packet, intentionally breaking the standard three-way handshake. So if address B replies with a SYN ACK or if address A replies to address B with a reset, both of those tell us the port is open. On the flip side, let's change port 80 with port 20. A closed port during a SYN scan is identified because address B immediately sends a reset ACK packet right after receiving address A's SYN packet. If we look closer by clicking on the TCP tab and sorting by port B, we can see a sequential list of ports, 1, 2, 3, and so on. This linear consecutive pattern is a textbook indicator of an active port scan. Every time address A sends a probe, address B responds with a single packet. If we look at the packet capture data, during a SYN scan, address B always replies with exactly one packet. However, address A will sometimes send two packets: the initial SYN, and then the reset packet after receiving B's SYN ACK. Because of this, when we count the packets for each open port, we will see a total of 3 packets in that specific conversation: SYN, SYN ACK, and reset. If we double-click to tab packages to sort them, we'll see that the ports with 3 packages are the open ports. Now we know how to use Wireshark to dissect the secret three-way handshake manipulation that makes this attack work. We know exactly how to spot a stealth scan, read the packets, and defend your network. Let's use a filter to see the closed ports. tcp.flags == 0x014. 0x014 means reset ACK, the response of address B, when a port is closed. Going to Statistics, Conversations, click TCP tab, and here we have 977 closed ports. To see the full conversation of a handshake on Wireshark, right-click on a conversation and select Apply as Filter, selected, Filter on Stream ID, or A to B and B to A. The first two options. SYN, reset ACK. Now let's use a filter to see the open ports. tcp.flags == 0x012. 0x012 means SYN ACK, and is the response of address B to a SYN packet of address A when a port is open. We go to Statistics, Conversations, click TCP tab and then click the tab Port B to sort the 23 open ports. To see the full conversation of an open port in Wireshark, right-click on it and select Apply as Filter, selected, A to B and B to A. SYN ACK reset. We can also see the open ports or the closed ports respectively, at the bottom right corner of Wireshark. Here from 2299 packets are displayed 23. These packets are the open ports. Now we know how to use Wireshark to dissect the secret three-way handshake manipulation that makes this attack work. We know exactly how to spot a stealth scan, read the packets, and defend your network.